Okay, this video is going to work through the review questions 35 through 39. And these are all related to the scenario here. In order to determine whether honesty is impacted by the use of electronic signatures, a study enrolled 45 volunteers. Each volunteer was placed in a room alone and given a multiple choice vocabulary test. After taking the test, each subject graded their own performance. Participants were then randomly assigned to one of two conditions. Either the subject was told to record their score and handwrite their full signature on a self-report page, or the subject was told to enter their score into a computer and enter an electronic signature. We will determine whether there is strong evidence that reported scores are different on average, depending on whether an electronic or a handwritten signature is used. So here is the stat key output with the descriptive statistics. We've got a side-by-side box plot, which is appropriate because we've got a categorical variable for our explanatory variable, which type of signature was used, and a quantitative variable for the response variable, which was the score that they gave themselves. So the first question asks, what percentage of people in the electronic signature group reported scores that were between 14 and 15? You can see 14 here and 15. 14 is the median. 15 is the third quartile, and we can see those here also. So we know the third quartile is the 75th percentile, the median is the 50th percentile, so there would be 25% of people who reported scores in between there. Okay, next question, we want to see, okay, we're doing this test to see if there's strong evidence that the reported scores are different on average between electronic and handwritten signatures. We want to know what the hypotheses will be that we'll test. So our null hypothesis is going to be that the two means are equal. The mean among electronic is the same as the mean among handwritten. Versus the alternative, we're trying to see if they're different. It's one not indicating which direction the difference would be in, so that's a two-tailed test. Not equal. We could also write these, of course, as the difference in the two means being equal to 0 versus the difference in the two means being not equal to 0. So if it turns out that the results of the hypothesis test are statistically significant, can it be concluded on the basis of the study that using handwritten signature caused students to report their scores differently? Why or why not? Now, it can be tempting to think, well, some people would score better on the quiz naturally than others, and so how can I tell? But remember that we used random assignment. And so what random assignment should do is it should make it so that people who would tend to score higher or lower in the quiz are evenly divided between the two groups. So because we have random assignment, we should in fact be able to make a cause and effect conclusion from this study. Question 38 asks which of the formula-based tests would be appropriate for testing our hypotheses. We're clearly interested, we've got one categorical and one quantitative variable, and we have two independent groups. So this is a situation where we would focus on a difference in means. The reason why I've got independent groups instead of paired data is because each person entered their score under one of the conditions, either with a handwritten signature or with an electronic signature, but not with both. And then 39 asks, if the p-value in the study were found to be statistically significant, what conclusion could be made? Remember that statistically significant means that we rejected the null hypothesis, and so we'd have evidence in favor of the alternative. And in this case, to see which direction the difference is in, we would need to come back and look and say, okay, well, the average reported score was higher in the electronic group than in the handwritten group, 13.41 versus 11.048. So here I can say there's strong evidence that people report higher scores on average using electronic signatures. That's the correct answer. And that brings us to the end of that set.